This is 9.1, starting a new chapter. This is dealing with the systems of equations. You've actually done this this concept for several years already, and with this chapter we're going to take it a little bit further into it. So we're going to start off with 9.1, and this may seem familiar, but 9.2 and 9.3 will get a little bit more involved. So here's a system of equations, and we're going to solve it. Well, notice, again, I have a system of equations. A system is just more than one equation. So it could be 2 equations, 3 equations, 4, 5, how many ever systems. And notice I have 2 variables. I have x and y, but I could have x, y, and z. I could have a, b, c, and d. I mean, I could have a bunch of variables. But for right now, let's start off with 2 equations and 2 variables. So to solve, there's different ways to solve. You could solve this by the substitution method, you could solve it by the graphing method, or you can solve it using the elimination method. There is another method that we're going to learn later on, specifically with bigger systems, you want to use another method. But for right now, this is just 2 equations, 2 unknowns. These 3 methods is all we need for right now. So let's look at an example. So here I have 2 equations, and I want to find the answer to this. Well, let's do it all 3 ways, okay? So I'm going to show you all 3 different ways to make sure you know how to solve. Let's first solve substitution. So if I'm solving this by substitution, I'm going to take one of the equations, and I'm going to substitute it into the other equation. So, and it's up to you which one you want. I'm just going to take the second equation. I'm going to take x minus y equals 2. And I'm going to, again, you could solve for x, you could solve for y. It's totally up to you. There's so many possibilities. But in this case, I'm going to solve for x. Now that right there is what x equals. So if x equals that, and notice that was the second equation, I'm going to actually take this and I'm going to substitute it in to the other equation right where x is. So now I have the original problem, x plus y equals 4, but I'm going to substitute that in. I'm going to change that to y plus 2. And then I still have this plus y. Notice I substituted the x. Instead of x, I wrote y plus 2. And then I'm going to solve this. So that's 2y plus 2 equals 4, y equals 2, and y equals 1. So, and you're like, a lot of students might just stop right there. But remember, it's 2 variables, x and y. Well, I know y is 1, so if I substitute that back in, that means x is 3. And notice this is a point, x, y, so 3, 1 is my answer, and I solved it by substitution. Now, let's solve it using elimination. So using elimination is a nice method, and so is substitution, so is graphing. They all have their advantages. So with elimination, you have 2 things have to happen. You're trying to eliminate one of the variables. And notice this, I have x plus y equals 4, x minus y equals 2. If you kind of think of columns, the x's line up in a column, the y's line up in a column, the equal sign lines up, and the numbers line up in a column. So I'm just going to add straight down. I'm literally just going to add the columns. So that's 2x. The y and the negative y cross each other out. They eliminate. And then I get 2 plus 4 is 6. And I'm going to divide both sides by 2. So x equals 3. And then once I solve for x, I need to plug that back into one of the original problems. So I'm going to plug it into this one. So that's 3 plus y equals 4, which means y equals 1. So 3, 1 is my answer. Notice I got the same exact answer. Okay, I'm just solving it by a different method. Now, graphically, what's taking place graphically? Well, if I take this first equation, x plus y equals 4, and solve for y, so that's negative x plus 4. Well, that's just a line. So I'm going to solve graphing a line, so that's positive 4. And then I'm going to go down 1 over 1, down 1 over 1. And I'm just going to do the slope. So this line is going to look like this. And then the other line, it's x minus y equals 2. I'm going to solve for y. I'm going to get this equation. So that's going to start at negative 2. And it has a positive slope. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And notice this line is going to look like this. Notice the point of intersection where they crossed is 3, 1. So I got the exact same answer using all 3 methods. So I wanted to show you could solve it using substitution, elimination, graphing. Either one of those 3, they all 3 work to get you the same exact answer. And again, that's a system of equations, and all I did was just 2 variables with 2 equations. Let's look at a word problem. You may want to pause the video so you can at least read the question and understand what's happening. So on this problem, you have $12,000 invested in 2 different accounts. And you can call it however you want. So, account 1, account 2, or A and B. Let's say X and Y. So I know X and Y are my 2 accounts. And I know one of them has 5% interest and the other one has 3% interest. So I'm just going to say this one is my 5% and this one's my 3%. Okay, so you should also remember that interest, we're talking about the interest on 2 accounts. Interest is PRT, principal times rate times time. And we're going to use that formula to set up a system of equations. Well, one system, notice I have I know whatever I have $12,000 and I'm dividing it between 2 accounts. I could have, 10,000 here and 2,000 there. I have 9,000 and 3,000. I could just have 6,000 and 6,000. I don't know how much amount I have, but I know I have a certain amount in X. I have in the account X, and in the account Y, I have a certain amount, and I know it totals $12,000. So that's what it says. $12,000 invested in 2 accounts. Now, again, I know the other one, I'm going to set it up using this formula, I equals PRT, and I'm going to do that with each account. So notice I have 5%. So if I literally take I equals PRT for this account, so I know the principal. That's what I don't know. I don't know how much I invested in here. So that's going to be my X. The rate for this account is 5%, 0.05, and the time is 1 year. So we're doing it in 1 year time. I didn't say that in the word problem, but it is. It's based on 1 year of time. Actually, I did. It says yearly interest was $500. So after 1 year, you earn $500. So this is 5%, and I know this is 0.03 Y. And again, the time is 1 year. So PRT, the time is just being multiplied by 1, so it's not going to change anything. So I know this. I know I have 0.05x plus 0.03y equals $500. The interest that I earned, this is how much money I put into the accounts. This is how much interest I earn. And now I have a system of equations that I need to solve. And again, you could solve this by elimination, substitution, or graphing, however you prefer it. So I'm just going to go and use substitution. And it's totally up to you how you want to do this. You can keep it as decimals, or just get rid of the decimals. It's up to you. What I typically like doing is I'm going to move the decimals over 2 places. So this red equation actually becomes 5x plus 3y equals 50,000. And I still have my blue equation, x plus y equals 12,000. And I'm going to solve this by using substitution or elimination. It's totally up to you how you want to do it. It does not make a difference. I'm going to go, like I said, I'm going to go and use substitution. It's totally up to you how you want to do this. So I'm going to take this equation and I'm going to go ahead and solve the blue one for x. So x equals 12,000 minus y. That's what x equals. And I'm going to substitute that into the red equation. So 5 times the x, and I'm substituting the blue in, 12,000 minus y. And I'm just going to solve that. So that's 60,000 minus 5y. That's negative 2y equals negative 10,000, which means y equals 5,000. So once y equals 5,000, we know this is how much money they put into this account, which means that means they put 7,000 into this account because the two together must equal 12,000. All right, let's look at another illustration. So here we have two equations, and we have two unknowns. We have x's and y's we got to solve for. So again, there's different ways to solve this. You could solve graphically. You could solve. You can't really use elimination on this, but you can use substitution, and that's what I'm going to do. I'm going to go ahead and solve this equation, this red one. I'm going to solve it for y. So y equals 2x plus 1. And then I'm going to substitute that into the blue equation. So the blue equation is 3x squared plus 4x minus the y, 7. And then I'm going to solve this. That's 3x squared plus 2x minus 8 equals 0. And then if I factor this, or you can do the quad, whichever one you want, but 3x minus 4, x plus 2, and then you're going to solve that, so x equals 4/3, and x equals negative 2. So we have two different answers. And again, you can check it using, solve it graphically, and you can check it, you'll see that they'll cross at those 2 points to be able to do that. And let's look at another illustration. So on this one, you can solve it substitution, elimination, graphically. So I'm just going to switch gears. I just wanted to show you different ways to solve it. You can solve this, again, by elimination, substitution. You can't really do elimination on this one just because you have x and x squared. Although you could cross out, I guess you could, because you could cross out your y's and then you would have two variables. You could do it that way if you want. But let's go ahead and use the substitution method on this just to show you. So if I solve for, again, it doesn't make a difference, but I'm going to go ahead and solve for y. So y equals x plus 4. And I'm going to substitute that in, so right there. So that's x squared plus x plus 4 equals 3, or x squared plus x plus 1. And it doesn't factor. And if you do the quad on it, you're going to end up with, x equals negative 1 plus or minus the square root of a negative number, which means there's no real solution. This would be an imaginary solution. So in this case, there is no solution for this, no real solution. If you check it by graphing, if you actually graph this, you'll see it as well. But again, that's how you would set it up and solve it. All right, let's look at another one. This one I'm going to solve graphically because the ln function, you don't have to. You don't have to use it graphically, but I've done all the other ones using substitution. So if you grab your calculator, if you type in ln of x, and this red one, this is y equals negative x plus 1. Negative x plus 1. And if you push graph, you can notice that it crosses at the point 1, 0. At the ln function, you have a line, and notice the point they cross at is 1, 0. If you substitute them back in, this is a way to check. I didn't say this, but a way to check all of these solutions. Just substitute 1, 0 back in. Remember, this is your x, that's your y. So if you substitute that back into both equations, it should work on both equations. And that's how you check each one of those. That's solving a system of equations.